right, I believe I am live. Thank you everyone who is joining me for this session. This is Practical Time Series Machine Learning. Just gonna pull up some slides here. Y'all should be able to see a title slide, Practical Time Series Machine Learning. This is the Data Science Innovators Conference. I am your host, Doug Wynne. Who am I? I'm a Director of Strategic Analytics at Comcast. I lead the econometrics team. We're focused on time series forecasting and analysis, which, as luck would have it, is the topic of today's conversation. Once upon a time, I studied economics in my undergrad at Cornell, joined the Peace Corps. After that, came back to the US, joined Moody's as an economist, where I kind of cut my teeth with kind of traditional econometric methods and time series regression. Realized I didn't want to be an economist for the rest of my career, so went and got my MBA, and as many good MBAs do, joined a consulting company afterwards, spent some time doing that, before making my way to Comcast, where I've worked in strategic analytics the entire time. And on the right-hand side there, you've got a picture of me in my natural habitat with my dog, Winston. So brief overview of what we're going to talk about today. I wanted to make this talk relevant both to those who are relatively new to time series, as well as hopefully the practitioners in the audience who are looking for some useful tips for applying machine learning algorithms, but also structuring successful machine learning projects. So we're going to start with a brief history of time series, do a little introduction, talk about some of the toolkit and methodology that we have. I'm going to talk about kind of the bread and butter of my team. We work on subscriber forecasting. So I'm going to talk, how is our approach? What do we, how do we structure it? How do we think about the output? I'm going to finish up my part with what I'm calling my six-step system for time series machine learning success and lasting happiness. Party face emoji, patent pending. Just some tips on what makes a good project and how do you make sure that not only are you technically sound, but you're also driving impact with the business. Or I guess if you're working in a different setting, whoever your stakeholder is, making sure you're driving the outcomes that they're looking for. And then we'll leave a little bit of time at the end for you to ask some questions of me. So there's two broad classification or categories of problems with machine learning or a lot of analytics that people do. The first one is classification, so things like binary outcomes. This might be customer churn propensity. It's a yes or no outcome. Either the customer churns or they don't churn. Churn means canceling their service, and we might come up with a probability of an individual customer based on the pieces of information that we know about them, whether or not they're going to churn. We also have continuous outcomes that falls into the category of regression. We might think of the average bill of a prospective customer. When you combine regression with the dimension of time, you get time series regression, which is the focus of what we're going to talk about today. Continuous outcomes that vary over time for an entity or entities. This might be, Comcast is split into 15 geographic regions. So we want to forecast the different order flows for each one of those regions over time. I'm not going to go into kind of the details of structuring and what the considerations are for time series modeling. So these are all things that you could look up on Wikipedia or wherever, but I broadly think about the toolkit of time series models in two buckets. You've got your traditional, mostly econometric tools, so things like linear regression, ARIMA modeling, it's autoregressive integrated moving average, and there's kind of different iterations, whether or not you're using exogenous variables or seasonality. Markov chains, I'm going to come back to this in a little bit. I think Markov chains are woefully underused, and they're near and dear to my heart because I think they're very useful in certain cases. And then just plain old indexing, right? Indexing from the prior year, the prior month, whatever your seasonal pattern is. There's a lot to be said for just simple methods and approaches. So if we think about those as kind of like the classic tried and true, I think of them as Sean Connery Bond, right? The classic Bond. But we're not here to talk about traditional methods. We're here to talk about time series machine learning. So there's all these other newer algorithms that have come onto the scene. In more recent years, a lot of the foundations go back a little while, not quite as far back as linear regression or Markov chains or anything like that. But we've got tree-based models, so things like random forest, XGBoost, light gradient boosting. It seems to be pretty popular now. You have Bayesian methods, Facebook Profit in particular. I believe, I'm not super familiar with Facebook Profit, but I believe in the back end it's a Bayesian model. And then neural nets. So if the traditional is Sean Connery, then of course this new school group is the Daniel Craig, sleek, modern methods. So that's a little background on time series machine learning. How does that apply in the workplace? How do I apply that with my team here at Comcast? The problem, the question that we face is predicting the number of net subscriber additions. So are we adding or are we losing customers on balance? We want to be able to predict that every day. Our executive leadership needs to know, hey, heading into this weekend, what are our numbers expecting to be? That this is one of the main determinants of our stock price that people look at when they're trying to evaluate the company. So it's really helpful for the leadership to be able to anticipate and get ahead of changes in these sorts of trends. It's across 15 geographic regions. I mentioned before, there's 3 order types. You can connect, you can voluntarily disconnect, or if you stop paying your bill, then eventually after a certain period of time, we will disconnect your service. And we want to be able to forecast up to 1 quarter in the future, so 94 days, forecast it each individually. So 3 order types times 15 regions times 94 days in the future means that we have 4,230 micro models that we run daily. And that's our approach. We have this stack of several thousand models, one for each of those permutations of the dimensions on the left. And for the most part, we're using an XGBoost algorithm. We did a bake-off of a bunch of different algorithms. We used Facebook Profit. We used a bunch of linear methodologies. And XGBoost by far and away gave us the best results. So that's what we work with. We work with a pretty limited feature set. Like I said, we run this daily. So being able to fit those delivery timelines and align with some of the existing data assets that the company has is really important. So when you're designing these problems or these approaches, there's often a push to include a lot of different features and all the possible information, but there's power and benefit to having a simple model as well. We also use some Markov chains as well. I mentioned that before, that they're near and dear to my heart. Markov chains wouldn't fall under the title of machine learning, but super useful, particularly for non-pay disconnects, because it's a pretty predictable and stable system that we're able to model with those. So I won't go into that here. We don't have the time, but I would recommend that as future reading for those who are interested. What are the results? I can't, unfortunately, provide any visualizations or anything like that because it's sensitive information. But it's a huge improvement over kind of the baseline forecasts that we were comparing ourselves against. So that includes both the prior year index. I had mentioned that prior year indexing actually often produces decent forecasts. That's what the business had been using previously, and it actually doesn't perform that bad, but we outperform it by a pretty significant margin. There's also a business forecast that the company teams of analysts who are using more traditional methods, Excel-based sort of things, are looking at the trends, extrapolating them out, and coming up with their view of what the quarter is going to look like. And we pretty consistently beat that number. We beat it more often than we don't. So we judge that as a success. And then the most important metric, by my estimation, it's in use from the business. So the executive leadership of the company is looking at this report on a daily basis to understand how are we trending? Are we trending up? Are we trending down? Do we need to intervene now with different strategy in order to hit the targets that we want to hit? So that was kind of the the technical side of things, I also wanted to talk about what makes a good time series machine learning project. This subscriber forecast has been probably one of the more successful, if not the most successful projects of my career. So I wanted to reflect back on what were the characteristics of the project that made it what it was or what it is today. First off, applying the right solutions to the right problems. When I started with this group several years ago, there was a quiet ban on doing linear regression analysis, and in particular forecasting, the sentiment being that when you're forecasting, you're always going to be wrong, which is true, but that doesn't mean that there's not a value in forecasting. So while I was working, in the beginning of my time here, I would find ways to insert, kind of clandestine regression into my work and tell, whoever was willing to listen about, why this is a better method and how this could, improve our work and give us more accurate results. Not necessarily putting it, still couldn't put it in the front page of the analytics, but, just getting it out there and putting it into the conversation. The second piece, finding your champion. It turns out that someone in the reporting structure above me had, he had gone partway through his PhD in economics. And so he was very familiar and sympathetic and understood the power of these tools. And had been kind of feeling on his own like, hey, we should be doing more of this. And we didn't quite have the skill set at the time. So when the opportunity came up where they wanted to stand up a team that was going to actually do this full bore, staff it up with the right people, I had established myself and kind of my interest in these techniques previously, which was how I made my way onto this team. Third, looking for highly manual legacy processes. There's a lot of things out there that are still done through probably not the most optimal methods, but you're looking for problems that involve a lot of data. They're highly dimensional. On the previous slide, we talked about all the different dimensions of the subscriber forecast. Those are problems that really lend themselves to machine learning approaches that are able to kind of incorporate all that information more than any human could ever possibly incorporate on a super fast basis. It takes about 10 minutes for us to fit all 4,000 of those models and provide a highly accurate forecast, which brings us to number 4, is much better than our baseline metrics. I think a failure point of a lot of projects that I've seen is not having that basis of comparison. So you do something whiz bang with forecasting or machine learning, whatever the tool is that you're using, but it's hard to say how much better is this than the way that we've done before. For us, like I said, we use the pacing index. We use the business knowledge forecast as our very indisputable goals of like, are we doing better than that or are we doing worse? So once we were at that point where we had the model, we were confident in the results, this is the part that probably took longer than it should have, frankly, for me to understand and come around to. But if you're in this field, if you're an analyst, you're probably pretty smart. And if you're familiar with the Dunning-Kruger curve, you're probably up on the end of knowing a lot and knowing how much you don't know, and maybe being a little uncertain or unsure, feeling like, oh, I need to learn more before I really put my voice out there. But in terms of dealing with stakeholders and getting your message out there, I think over communicating is what feels like over communicating often is just barely enough. So we send out a biweekly email to our stakeholders. We try to stay in contact with them as much as possible, just keeping them in the, one second. I'm at 15 minutes. I'm just going to finish up on this slide and then we'll hit questions. Keeping them in the flow of the project, making them feel like an owner rather than someone who just gets a report from this random person every once in a while, telling them how they need to do their job differently. That's not a good relationship. You want to have it more interactive and integrated. And lastly, staying humble. You know, when you do have the great model that is outperforming and whatnot, it's great, but it's not going to last forever. Eventually, something's going to go wrong. And those conversations are much easier to have when you're having them with someone that you have a good relationship with and you've built up some goodwill with, rather than someone who you've spent the last, you know, half a year talking down to. So stay humble, stay happy, stay interested, and you will have lasting success and happiness with your time series machine learning. All right, so thank you for coming. I think we got about 5 minutes now for if there's any questions in the crowd. I am on LinkedIn, so if you just search for me or go to that link down there, you can find me. If you want to drop a note after the presentation, that's fine as well. Thank you. And if we don't have any questions, then I can talk a little bit more about some of the technical pieces. Give it another minute if there's anything that comes up. Oh, is there, sorry, there's a chat. I thought you'd be able to talk. Okay, so I see, how do you determine when a Markov chain is appropriate? Yes, a great question. Markov chains, let me actually put a slide in this at the end. Here's a visualization of the Markov chain that we built for non-pay disconnects. Non-pay disconnects, we schedule those like 30 days in advance, right? You don't pay your bill for like 60 days or something, and then the disconnect gets scheduled 30 days in advance. So we've got a good leading window of when that's coming up. And there's two outcomes that can happen once your customer is scheduled. Either they can cure, they can pay their bill and the order gets canceled, or they can either disconnect from their own volition, calling up and saying, hey, yeah, I know I'm back on my bill, I just want to disconnect, or they reach that scheduled point and we actually go out and do the disconnection. So when you have that kind of very stable, it's just a question of like how many customers are going to cure in each one of these periods. That we've tried to apply it to some other areas with less success, but that specific context is very powerful for that. How did you decide the segments that you built your micro models for, and what are the approach you used for those models? Yeah, so the segments, that was really driven by the business. The business, they were split into those geographies. The 3 order types, that's just how customers come in or out. So I guess to answer your question, it's really in conjunction with the stakeholders understanding what are those important dimensions that they need to be able to say, that's great that the aggregate forecast is X, but I want to know this specific region for connects, are we doing better? Are we doing worse than what we were doing before? The approach we used for those models, we did some hyperparameter tuning, but mostly it's kind of just off the shelf. XGBoost gave us very, very good results. Take one more question. My journey into data, that was the front slide. Really starting as an economist and just kind of falling in love with more of the advanced machine learning sort of approaches, and eventually, finding my way into a role and a career where I could work exclusively with them, and not be limited to kind of your more traditional. The more traditional are great. Sean Connery, we love him, but there's a lot of benefit to the Daniel Craig good new methodologies as well. And then lastly, statistical software used for running these models. We use Python. We use Python in Databricks. So I love Databricks is not paying me to say this. I love Databricks. I love just being able to spin up a cluster with however many CPUs or RAM that I need. It's incredible. So allows us also to do the automation and kind of fire that automation based off of other triggers earlier in the day. So when we're aligning to other reports. Yes, so okay, so I'm a minute over. I know I'm supposed to be on time so I don't mess up the schedule for other panelists. Thank you so much for coming. please, if you have more questions, I know I didn't get to all of them, drop me a line on LinkedIn, and hope to hear from you, and best of luck with your machine learning time series journeys.